Okay, we're done. Summary. Let's talk about this. The center of gravity. It's that spot where the sum of all forces of the gravity act. Now, and again, it may or may not be on the body. Don't get hung up if the most obvious example is think of a washer, right? Or a donut. The center of gravity is going to be right in that hole, right in the middle spot. So it's not always on the body. We talked about centroids and first moments. So the centroid of an area is the center of gravity for a homogeneous body. The first moments are qx and qy, right? And we use those in and of themselves, not overly helpful, but we use them to find the centroids. The first moments and centroids, we talked about the first moments and centroids for symmetric areas, how the first moment about an axis of symmetry is going to be 0, and the centroids are going to lie on the axis of symmetries. We talked about centroids of composite plates and areas, how we can start dealing with each plate is kind of its own thing, and then add up the total effect from those. And the determination of centroids by direct integration. And remember, the way we're going to do that is we're going to use these vertical and horizontal strips. Usually we're going to use vertical strips just because it makes the math is usually easier, but you can do it any way you want. We talked about the theorems of Pappus Guldinus, which it gives us a way to calculate the surface area of when you rotate a line or a curve, right? And the volume when you rotate an area. And then we talked about distributed loads on beams and how we're going to integrate up the curve to find the magnitude of the load, and we're going to find the centroid of the curve, and that's going to be where it applies. And then after we did all that, we talked about the 3D, how all these same principles are true for 3D. And that is it.